All right, so this is going to be Unit 7, Lesson 2, Question 2, a central relationship. So in this question, we're going to compare and contrast. How does something like this, a central angle, compare to something like this, an inscribed angle? So they are different. They have different qualifications. They have different relationships with the arcs that they intercept and everything. So hopefully in this question, we'll clarify some of those things if you have been thinking about them. So in this question, we need to use a protractor. If you don't have one, well, I'm going to do the measurements for you anyways. But if you do have one, I'll also link the PDF so you can follow along and do this on your own. Hopefully you find value in finding some of these questions out by yourself. So it says use a protractor to find an approximate angle measure for angle QAC. Angle QAC starts at Q, goes through A, ends at C. So QAC is this angle here. Okay, so let's find the measure of this angle. If I put the center point here and line up these lines, let's see where it ends up. So you start from here, 10 going up through. It looks like it's 80 degrees to me. So I'm just gonna go ahead and say that. If you wanna be more precise, knock yourself out, but 80 seems pretty good to me. Next, it says mark a point B on the circle that is not on the highlighted arc from C to Q. So it's not on this arc here. So each member of your group, obviously we're not in groups, should have a different location for point B. And I honestly do not care where you have point B. So I'm just gonna put it here. If you are following along on your own paper, I don't care where you put it, just so long as it's not between C and D. So that so long as it starts from the C and you go to the left all the way around to Q. I don't know why I just said D. Anyway, my bad. Let's see, each member of your group, blah, blah, blah. Draw chords BC and BQ. So I'm going to use a straight edge to draw these in. I should probably use like just a normal generic looking color pen. All right, from C to B and from Q to B. All right, so there is our chord. I probably should have drawn it over here. Oh well, whatever. That's just the way it looks, okay? If your B looks different, that's fine. They shouldn't overlap, and you can see that here. They are not overlapping, okay? Let me zoom back out. Yikes. All right. Okay. Use a protractor to find the approximate angle measure of this angle. So I'm gonna highlight angle QBC. QBC starts at Q, goes through B, ends up at C. So that one's going to be highlighted yellow. And let's find the measure of this angle. So again, B goes in the hole, and then you want to line up this line with the bottom side of that angle as best as you can. And then since I'm starting at this angle, I'm going up. I'm going to start with these numbers here, and that looks like it ends up at like 40 there. So let's write that in. 40 degrees. So let's say this one was 80. This one is 40. Use a protractor, okay? Next, it says share your results with your group. What do you notice about your answer? So what you guys would have noticed, and what you can do by yourself if you want to do this, is that it doesn't matter where you put B at. The measure of angle QBC, no matter if the vertex is sitting over here, if it's sitting over here, if it's sitting directly like in line with A, it is always going to be about 40. That's what you guys would have realized if you guys were in class with me doing this, okay? And then the last question is number 4. Make a conjecture about the relationship between inscribed angle and the central angle that defines the same arc. Okay, so it defines the same arc means its endpoints are the same. So the endpoints of angle B here are C and D, and the endpoints of angle A here are C and D. So that's what it means there by it defines the same arc. And here's a conjecture. So you can see that it is exactly half the measure. So that's what my conjecture is, and I hope that this is going to work. Oops, can't see. You can see here that 40 is half of 80, okay? So maybe if this angle was 60 degrees, would this one be 30? If this angle was, I don't know, 120 degrees, would this angle be 60? I don't know. So, but that's my conjecture, that the measure of the inscribed angle is half the measure of the central angle. So long as both the central angle and the inscribed angle intercept the exact same arc. Okay, so that's what it looks like to me. And then so based off of this, the synthesis question is here. So it's pretty much, what do you notice here? And here's some other examples. Again, this is the central angle, and this is the inscribed angle. Half of 130 is 65, so that one works. This is the central angle. Even though it's a straight line, it's technically a straight angle. It's 180 degrees. And this is the inscribed angle, 90 degrees. 90 happens to be half of 180, so that one worked. And then lastly, here's the inscribed angle, and it's bigger than 180, so this angle is actually 220 degrees. And so this angle right here is 110. So again, half. So that's going to be the definition. I'll show it to you guys next. Is that it's called inscribed angle theorem. And inscribed angle theorem says that any inscribed angle is going to be half the measure of its, right here, this is better, half the measure of the central angle that defines the same arc. So long as they're both crossing the same 2 points, they're going to be half. That's going to be the relationship. Half.